You know, one common issue that many RV owners have is your batteries dying on you while you have them in the storage. This may be more common than you think, and if you go on any of the RV forums, you'll see a lot of people have issues when they store their motorhome. After just a few short weeks, everything is dead. All their batteries are dead. Well, there's a couple reasons for that. One issue is that just naturally over time, the battery will self-discharge. If you're storing your RV for 6 months, chances are the batteries will be dead when you get it out of storage. So one thing you may want to look at doing is to keeping a charger voltage on your batteries while they're in storage. The other reason may be the batteries may not really be truly off when you think they're off. Now, most RVs and motorhomes do have a disconnect switch so that you can disconnect the battery from the system, but that isn't always an absolute. There may still be some loads on the battery even though you may disconnect it. With the modern day RVs, you've got, not only the DC systems, but you've got typically an inverter or maybe a generator or solar power. And in the case of motorhomes, even the engine battery may be charged by the coach battery, or the coach battery may be charged by the engine alternator. So you can really get into some very complex issues here. But today what we're going to concentrate on is how to see if your batteries are truly disconnected when you think they are. Now, the battery tray in this RV is kind of complex. Typically, you should never have any more than 2 connections per battery post, at least in keeping with good practices. Well, we've got 2 batteries that are in parallel, so obviously we have to have 2 connections between the batteries. But here we've got the main connection going to the house systems, and then we've got another connection going to the aftermarket hydraulic leveler system. Even though we think we've disconnected the battery, there still may be some loads on this battery that are draining it. Now, in this coach, we have an automatic contactor on-off switch rather than a mechanical on-off switch. I actually prefer the mechanical ones better. The way this works is you turn it in that position to turn it off, and you may have heard a little clunk. That's the contactor. And to turn it back on, you hit the other button like that. Now, the reason I don't like this is because if you're in a boondocking situation, for you to use your batteries, turning this on has to keep that contactor energized, and energizing the contactor in itself is going to drain the batteries a little bit. So that's kind of a silly way to do it, I think. But nevertheless, one of the things I want to demonstrate today is how much load your batteries are actually under when you think you've got everything disconnected. Now, the way that we're going to tell if we have any issues with any residual loads on our batteries once we turn them off is by using one of these clamp meters. Now, some people refer to this type of load as a parasitic load, and I suppose you could make a case for that, although it is a bit of a misnomer. But if you want to call it a parasitic load or just a residual load or whatever, it's a load that is on your batteries that shouldn't be there when you shut them off. The only way you can tell that is by measuring the current going out of the battery when the power is completely disconnected. I've got 2 clamp meters here. This is a B&K Precision Model 316, and it's a micro clamp meter, and this costs in the neighborhood of around $150. This is a Mastech model number MS2108A clamp meter, and this is around $40, so this is much more reasonable. This meter is limited to about a 1/2-inch diameter cable, where this one can handle much larger size cables. Now, the main thing between these two, other than possibly build quality, is that this is a little more sensitive than this one. And what I mean by sensitive is that it can read lower currents a little better than this one. But this one doesn't do a bad job. And in fact, I would recommend buying this one first, and then if you want them both, of course you could buy them both. For $40, this is actually a pretty decent meter. Now, when I bought this meter, it came in a package with all the writing being Chinese. Fortunately, the owner's manual was in English. This is a little harder to set up in some cases because it has sub-functions that you have to set up. But once you're familiar with it, it works pretty well. One thing I like about this, though, is that there is a little light right here, so it'll light up your way. Now, the way these work is in any cable, and we'll look at a battery cable here. As current goes through the cable, it generates a magnetic field. Assuming this is a battery cable, basically what you do is just clamp it like that, and then it's going to read. Now the thing is you have to make sure these jaws are closed. If the cable is such a size that they remain open, say like that, you're not going to get an accurate reading. So what we're going to do is we're going to take these two meters and we're going to test them both out, see which one's more accurate, and see if we can measure any residual loads on the system after we shut the power off. So I've turned on a couple of the overhead lights in the coach just to give me some way to do a reading, and I'm going to use this meter first. So I'm turning this on. First thing I'm going to do is push this to zero it, and you see that this is 0, and then clamp it, and you can see that I'm measuring 1.8 amps. And again, I've got a couple lights on. So now I'm going to disconnect the battery, and when you see this, I'm measuring about 15 milliamps. So even with all the power off, I'm still getting a little bit of a load on here, 15 milliamps worth. And when I disconnect it, see, it goes down to almost 0. Now on this meter, we'll try the same thing, although I got to set it up a little bit differently. I can turn it on to the low range, and then I got to move the selector switch so it reads DC, and then you still have to zero this. There we go. So, and actually I'm going to turn the light on here to make it a little easier to see, a little easier for the camera to see. So I'm going to connect, and this one here shows 2.0 amps, and this actually shows quite a bit more. This shows about 130 milliamps. So there is a little bit of a discrepancy between the two meters. The meters themselves generally are only accurate by about 2% anyway, but you can see where this meter actually has a little more resolution than this. Okay, I want to zero it out. I want to measure this lead, and this lead is the one that goes to the automatic leveling system, hydraulic leveling system. And again, I'm showing a little bit. It's bouncing around a little bit, but it's kind of unreliable. So now I'm going to try this one, and again we're going to zero this out, and I'm going to have to put the camera down for a second because this is going to have some help in connecting because of this loom on the wire. So on this one, we're measuring about 27 milliamps. Now the one thing that you'll notice here between these two meters is they're not too consistent. Each one measures a little bit differently, and that's probably more of a problem with this meter than with the more precision meter here, just simply because this one's designed for the lower currents. It probably doesn't really matter as much the exact measurement as it does the fact that you can measure some current, and whatever you do to find that and reduce that current will be reflected in the new reading. This is kind of a little, maybe a eye-opener for you if you buy one of these meters and find that indeed your batteries, even when they're supposedly disconnected, are actually still losing some charge to some residual things that are connected. Before we conclude on this, I'm going to take these two meters in and compare them and see what the lowest reading is, and I'm going to set up a little circuit with a LED that could represent just a small LED being on, and then we'll compare from there. So I'm sitting in here in my electronics shop, and what I have is I have an LED here. You can see that it's lit. on a 470 ohm resistor going through my 12 volt bench supply. And the 12 volt supply is saying the amount of current that's being consumed is 18 milliamperes. So with the first meter, you can zero it. Okay, this is showing about 23 milliamperes. So, there is a bit of an error here. It's off slightly. With this meter, okay, see this shows about around 40, 50. It's all over the place. 40 or 50 milliamperes. So you see this one is not anywhere near as accurate as the P&K. So for this demonstration, I've used a couple power resistors so that I can get about 180 milliamps of a load through this just a little test mock-up. So I'm going to turn on my meter here, and now I'm measuring 190, 180 milliamps, somewhere on there. And again, we're looking at 180 milliamps or so. So if I turn the power off, it goes to zero. Turn power back on. So now we'll try the other meter. Okay, 181. So power off. A little more residual there. Power on. Okay, 181 again. So how significant is 180 milliamperes? Well, if you take 180 milliamps and resolve that into a 200 amp hour battery pair, that is two group 27 batteries that are connected in parallel, it's going to give you somewhere close to 200 amp hours. And even at this load, with an 180 milliampere load, about 45 days and the battery will be completely discharged. And so that's real world. I mean, you could fairly easily have a battery sitting in storage in your RV completely discharged in 45 days. So in that regard, both of these meters are sufficient to detect currents low enough that could discharge your RV in 45 days. So either one of these would work. If I were going to buy just the one meter, I would buy this one because it's a little more easier to use. It's got a little more functionality, and even though it's not quite as sensitive as this one, this will be useful probably in most RV situations, and it's a lot cheaper. It's about 1/4 the cost. So anyway, hopefully this will give you some insight as to why your RV may be discharging during winter storage, and how to measure that to see if that's actually happening. And then, of course, you're going to have to do some troubleshooting and find out what it is that is causing that drain. It could be anything from a radio keep alive circuit. They may have hooked the refrigerator in or something, the control board, because all the appliances, the refrigerator, the water heater, and the furnace, all of those devices, even if they run on propane, have DC control boards on them. So there's quite a few things going on that could draw the batteries down. And the only way you're ever going to figure them out is if you use meters like this and do an analysis and find out what's discharging and what stays on when you turn the battery switch off.